Hi, welcome once more to another video. And in this video, we'll be continuing with our topic, which is trigonometry. And trigonometry, we said, is a topic that cuts across all engineering courses, from mechanical, civil, electrical. Remember to subscribe to the channel and also like the video is very key. Liking the video helps the channel to be promoted to more engineering students so that they can also benefit just like the way you are benefiting. So it will be very wrong and unfair if you usually watch my videos and leave the videos without liking the video, and yet you feel the videos are really helping you in your studies. So that won't be good at all. So for this particular video, we will solve a mechanical engineering question, but I wanted to skip the first part of the question. And this paper is for diploma in mechanical engineering, production option, industrial plant option, automotive engineering option, welding and fabrication option, construction plant engineering option. I've mentioned about all those diploma engineering options in my past videos, especially the videos for career guidance. If you have not checked the video, you can watch it in the link shown here. We'll solve question 2b. I'll skip question 2a for the time being for a while. Prove the identities. We are told cos 2 theta, number 1, cos 2 theta is equal to 1 minus tan squared theta all over 1 plus tan squared theta. If we now take the right hand side, taking the right hand side, we know 1 plus tan squared theta is equal to sec squared theta. And we also know sec squared theta is equal to 1 over cos squared theta. We can also say tan squared theta is equal to sin squared theta over cos squared theta. Let us make this substitution and this substitution. So we have taken the right hand side. We have 1 minus tan squared theta, which we are substituting for, sin squared theta over cos squared theta is equal to 1 plus tan squared theta is equal to sec squared theta. Sec squared theta. Here on the numerator we can say this is cos squared theta minus sin squared theta all over cos squared theta. Make cos squared theta to be the LCM all over. What is sec squared theta? We have said this is 1 over cos squared theta. Of course, we can write this as cos squared theta minus sin squared theta all over cos squared theta divided by 1 over cos squared theta. So you can say this is division, which is cos squared theta minus sin squared theta all over cos squared theta times cos squared theta all over 1 if you do the reciprocal. So that this can cancel out with this. So that now we can say the right hand side is cos squared minus sin squared theta, of which is equal to cos 2 theta. But we also know, now I can remove this, but we also know from another identity, trigonometric identity, cos 2 theta is equal to cos squared theta minus sin squared theta. The left hand side, which is cos 2 theta, is equal to right hand side, which is we have simplified to cos squared theta minus sin squared theta. So that is it for that one. Now solve the second one. Lemma 2, we are told we prove the identity. It was also about proving identity. 1 minus cos 2 theta or over sin 2 theta is equal to tan theta. I think this is the last identity of this type we will be proving. Because you have already proven quite a number of identities. If you have not checked the videos, you can check them on the link shown here or on the video description here. Also on my video description, you see the link to my paper. If you'd like to donate to the channel through paper, you can also donate to the channel through the Mpesa Buy Good Till. I've also provided it there. Taking this is the left hand side. We know sin 2 theta is equal to 2 sin theta cos theta. As well, cosine of 2 theta is equal to 1 minus 2 sin squared theta. These are called the double angle formula, sin 2 theta and cosine 2 theta. So we are going to make those substitutions, which will give us 1 minus, instead of cosine of 2 theta, we will say minus 1 minus 2 sin squared theta or over 2 sin theta cos theta. It now becomes 1 minus 1 plus, because if you open the bracket, this minus is plus, 2 sin squared theta or over 2 sin theta cosine of theta. If you 1 minus 1, that is 0 plus 2 sin squared theta or over 2 sin theta cosine of theta. So the 2 will cancel the 2. One of the sine term here will cancel with this sine term. So that finally we have this is sin theta or over cos theta, which will give us tan theta. So we can see the right hand side, not the left hand side, has equated with the right hand side, which is also equal to tan theta. So that's how we go about that. But one secret about being able to prove the identities is learning as many identities as possible. Another mistake I see students doing is not regularly having their S&P tables, because all these identities I'm bringing about, most of them are already in the S&P table. So even you would not need to struggle to remember them. You will always find them in the S&P table. But of course, you might need to be able to derive a few. Not everything is in the S&P table. Now, question 2C, let us do something a little bit different. Question 2C, we are told, solve the equation. Sin x plus 20 degrees multiplied by cos x minus 20 degrees is equal to 0.6. Sin x plus 20 degrees times cosine of x minus 20 degrees is equal to 0.6. For the values of x between, for the values of x between 0 degrees and 360 degrees. Inclusive. Inclusive means you have to solve all values of theta where that particular trigonometric function is either negative or positive. You have to check where is it positive, in which quadrant and what quadrant, or where is it negative, in which quadrant and what quadrant. That's what we mean when we say exclusive. Using your S&P tables, you check where you have the trigonometric identities. We know sin A plus B is equal to sin A cos B plus cos A sin B, and cosine of A minus B is equal to cos A cos B. If it's minus here, it's plus sin A sin B, which now means sin x plus 20 degrees is equal to, which is now equal to sin x plus 20 degrees. This is sin x cos 20 degrees plus cos x sin 20 degrees. This is equal to cosine of 20. Cosine of 20 is equal to 0.9397 sin x plus sin 20, which is equal to 0.342 cosine of x. Then we have cosine of x minus 20 degrees is equal to cos x cos 20 plus sin x sin 20, which is equal to 0.9397, similar to this one, cos x plus sin 20, similar to this one, 0.342 sin x. Now we can multiply the two. Sin x plus 20 degrees times cos x minus 20 degrees is equal to 0.9397 sin x plus 0.342 cos x. That's yeah, need more space, times 0.9397 cos x plus 0.342 sin x. So that now we have if you multiply this and this is 0.883 sin x cos x. We have this and this, we have 0.9397 times 0.342 is equal to 0.321 3 or 4. If you round off sin squared x plus multiply this and this, it will be the same, 0.3214 is cosine and cosine, cos squared x. If you now square 0.342, both this term and this term is the same as squaring. If you square that, you get 0.117 if you round off sin x cos x. I hope it's still visible on the screen. So now we have 0.883 sin x cos x plus 0.342 117 sin x cos x plus, if you factor out 0.3214, 0.3214, factor that, you have here inside sin squared x plus cos squared x is equal to, this one you are supposed to equal to with what? To 0.6. So I should be equating this term and this term finally should be equated to 0.6, and this term finally should be equated to 0.6 is equal to 0.6. So that we add, we have plus 0.883 plus 0.117, that is 1 sin x cos x plus, see, sin squared x plus cos squared x is 1. The order of this bracket is 1. 0.3214 equal to 0.6. So sin x cos x is equal to 0.6 minus 0.3214, 0.2786. But if we multiply both sides by 2 sin x cos x is equal times 2, 0.5572. But this, the whole of this is sin 2x. This, if you use trigonometric identities, this is sin 2x, 0.5572. Now, we can find, if you apply sin inverse on both sides, sin inverse sin 2x is equal to sin inverse 0.5572, or sin inverse sin, you cancel to get 2x is equal to sin inverse 0.5572. But if you get the sin inverse of the answer, you get 2x is equal to 33.86 degrees. But you know, sin is positive in the first, second quadrant, third turn is positive, fourth cosine is positive. So we want answers in the first and second quadrant. For the first quadrant, if you divide both sides by 2, the first value of x will be divided by 2, 16.93 degrees. The other one, 2x. You see, this answer you got from the calculator. 180 degrees minus 33.86, which is 2x is equal to 146.14 degrees. Or x is equal to, divide by 2, which is 73.07 degrees. So that's how you solve when you're told exclusive, because here the value of sin was positive. I mean that this value which you are supposed to get the sin inverse is positive. There is an angle in the first or second quadrant whose sign is positive. That's why we are told to solve inclusive. You must get these two angles. Sometimes there will be even before angles depending on the type of question. So that is it. Remember always to support the channel. You can support the channel in different ways. By donating to the channel if you download the videos, or by watching the videos online. You can also attend my online classes by sending an email to the email shown on the screen, so that we can make arrangement on how or which topics I can take you through. If you are a group of students, it will be even much easier because it will be more effective to handle a bigger group of students than just a single person. But either way, it can always work. So that is it. Let's meet in the next video where we will be attempting another mechanical engineering question or a question from the electrical engineering past papers.